least 1 hour. Okay, okay. Uh, yeah, my presentation is visible. Okay, okay. Okay, thank you. Hope my presentation is visible to you. And
Yes, clearly.
yeah. So one thing is that already my colleague has given one lecture, maybe on the fundamentals of remote sensing for agrometeorology, and I think he must have covered many of the things. But still, I will bring some unique things which you may like, and from where to where we are going, and how satellite remote sensing really can help for agrometeorological applications. There are many applications of remote sensing today's age in agriculture, but I will restrict my presentation only to agrometeorology. So this building is actually of Space Applications Center, which is one of the major center of India Space Research Organization located at Ahmedabad. And we have actually two campuses, one major campus and another 5 kilometers away. The center actually makes payloads of the satellite for remote sensing, navigation, communication, as well as you have the applications teams for application areas for remote sensing in various domains, including agriculture, forestry, where I am group director, and as well as for satellite navigation and communication. So with that brief introduction, I'll just go to my next slide. So uh, yeah, so these slide shows that how actually risks occur for agriculture, and which are mostly driven by the weather factors. And you know that it causes the abiotic and biotic stresses. If we talk about the heat, water, nutrient, and if we talk about pest and disease and the biotic stress. So basically soil, crop system and weather and climate, how these are interacting and impose threats to the crop production systems and also soil systems that actually impose the risks. So these actually constitute to the production risks. And another very important risk, which is the market risks, that whether nearby market is available or not, and also during marketing there are also logistic challenges which are mostly imposed by weather. So farmers' livelihood actually depend how they can manage the risk better in an efficient way, and how to mitigate that so that their livelihood can be saved and also enhanced. So our objective is to how we can go for the agrometeorological risk mitigation. So there are short-term and medium-term risks for which, if we can manage, so that can enhance the livelihood of farmers. And some are actually very long-term in nature. That I will come in the next slide. This risk mitigation actually can be in two ways. One is the risk assessment and the prediction, and another is the risk minimization and the protection. So risk assessment generally can be done through weather forecasting, and today's age we require very high resolution weather forecasting, and then medium to extended range with improved accuracy, especially for rainfall, temperature, wind, sunshine hours at the local scale. And there is a need for the prediction and maybe extended range prediction for the extreme events, We have improved in weather forecasting and all this, but still I think some more to be done. And here also satellite play a very important role. I'll give you some examples later. And then risk minimization and protection, where Agromet advisory services towards higher granularity. That means if we talk about district block, now we should move to the village and maybe finer than that. That sort of advisory services we require, maybe for the pest advisory, maybe for the irrigation management, or maybe for the intercultural operations. And then another risk mitigation scheme, which is actually the crop insurance, whether there are two parts, that this crop insurance is based on the weather for assessing the midterm adversaries, and also area yield based crop loss assessment or crop yield assessment. So these two are primary drivers for crop insurance settlement claims of the farmers. And another important thing is that how we can optimize the input used for the agriculture, especially in a farm, but without reduction of yield, so that there will be more input use efficiency and there will be less impact to the environment. And fourth is drought. We have done a lot of things on drought assessment, improvement, and early warning and relief are main challenges for the drought, especially for the drought early warning and the drought forecasting and all these things. Now, let me tell you about the long-term risk drivers, which actually occur from the climate shifts, and it causes to the vulnerability. So, because of the climate shifts, whatever climate zoning or agroclimatic zoning has been done, those are actually being periodically shifted. So, we have actually long-term data from satellite, maybe at different spatial resolutions. However, these can be utilized for the definition of the new kind of agroclimatic zoning with finer granularity, which we call the digital agroclimatic atlas. That is our first priority, present priority in our research. And soil erosion zoning, and you know that land degradation, desertification, and land degradation neutrality, especially when Prime Minister has announced in COP26 that India will achieve 2070 the carbon neutral ecosystem. So we should also focus for the carbon neutral agriculture. And for that also, this periodic soil carbon assessment is very, very required. And another very important thing is that how to identify the potential surface and groundwater availability. And what are our agro-hydrological options? You know that for a watershed, and especially for the micro irrigation, there are challenges is that a lot of groundwater extraction happens, and in different parts of the world where sound water policies are not existing, so their over exploitation of groundwater leads to salinity, then pollution, and also the less availability of water for the irrigation. So there should be a measured policy for the water usage in agriculture. So these are the long-term threats which are related to primarily to the policies and all. So how satellite remote sensing can play important role, and satellite remote sensing should be connected. Data should be connected to the geospatial platforms. As you know that today's age, we talk about some front end and back end. So basically, satellite data products actually are being used as the back end data support, and the front end will be the geospatial platforms through which you can do a lot of analytics. So we primarily have the polar orbiting and the geostationary satellites. I hope these basic terms you may be familiar, and we can get the large area imaging from satellite at multiple bands, optical, thermal, microwave, and this remote sensing has both passive and active. Active, mostly it is the radar remote sensing. Now, the advantage is that satellite remote sensing can give you data in a fixed orbit and in a very fixed temporal revisit period. So, through the orbiting data, so we call recently the new term has come that orbiting intelligence. So, a satellite actually remote sensing actually provides the intelligence from the orbits. And the data comes in a very electronic manner. So automated quick accession of the data processing, first generation of the science products and monitoring can be a possibility. And some of the examples I'll show you. And there are scope for different sampling and the scaling at the different resolutions from the native resolution of the satellite data, and whatever products we are making, that can also be assimilated, especially for the land data like soil moisture, then leaf area index, and then fractional vegetation cover. All this can be assimilated to weather forecasting models. So in many countries these are happening routinely, but in India I'm not sure. But these data assimilation should be for the high resolution short term to medium range weather forecast. And it can be useful for developing ecological models for the larger perspective. And many times the satellite based meteorological variables or the land surface variables that can act as a surrogate for in situ data where sparse network exists, and it reduces human interferences and maybe sometimes increases the cost effectiveness. Digital interpretation, and so far we call the digital agriculture. So the satellite remote sensing data and products act as assets to the digital agriculture. Now, if we talk about the front end, the geospatial platforms, it can provide you the mostly it should be on the GIS, Geographic Information System. And now people are talking about the data analytics through the AI empowered data analytics on web GIS. And web GIS should not give only the data analytics, it should lead to some decision making ability. So dashboard people are making, and also accessibility of these information through the API and mobile apps are actually is enlarging. And there are also facilities to upload the citizen-centric science data, and maybe this in many of the cases these platforms act as digital twin, means from both sides. So from user sides and from the developer sides. So this has a lot of advantage, but until and unless we have the proper back-end data, these geospatial platforms have no meaning. So these two actually go simultaneously. Now I'll move to the very important part, that what are the essential agricultural variables for agrometeorology from satellite remote sensing. Now, though I used to talk about these for a long time, but GeoGLAM, that is Global Earth Observation Initiative for the global level agriculture monitoring, they are emphasizing on these essential agricultural variables, EAVs, similar to the ECVs, like essential climate variables. So the boxes which I have made here, there are many variables which are required for agrometeorology. But as per GeoGLAM, all variables are not actually emphasized for the EAVs, but the variables which are in the boxes, those are actually defined by them. So, what should be the spatial resolution, and how means what should be the temporal resolution? That actually is has been defined. There are good papers available also. Indirectly, I am also connected to the GeoGLAM EAV team through from ISRO. So crop variables include the net sown area and then crop type, leaf area index, fractional absorbed part, and vegetation traction. I think all these things you are actually very much familiar. Crop biomass and primary productivity slash yield. You can see the paradigm shift in satellite remote sensing. We are talking now about the quantitative variables. We are not talking about the vegetation indices. So this is the shift that where we are talking about the primary variables which are actually required for the assessing the agriculture system. So not in terms of the indices and indicators. So this crop type and crop map is fundamental requirement for any agriculture exercise. And if you want to know the biophysical constraints, or if you want to know the how pest and disease impact on plant, so definitely there will be reduction in leaf area or maybe fractional vegetation cover or so, or maybe in the biomass. Yield loss, biomass loss is one important input for the insurance claim settlement. And similarly, if you look at the soil variables, the surface and root zone soil moisture as at less than equal to 60 meter daily is required. And soil and canopy temperature, land surface temperature, less than equal to 60 meter at 1 to 3 day interval. People are expecting much more than that. Maybe if you give this temperature at 1 meter, they will be very happy. But we have to make some trade-offs between what are the available data, or maybe what can be possible in terms of signal to noise ratio from satellite data, and what is our expectation. So some trade-offs are there. So based on the trade-offs, these are actually made. And if you see the another important agrometeorological variables, that is the actual evapotranspiration, which is linked to potential also. But however, apart from that, what I believe is that there are very important variables like meteorological variables which can be derived from satellite data and very much useful, like rainfall, then shortwave radiation, or what we call the surface insolation, and also there are important variables like soil carbon, nitrogen, soil salinity, etc. And water stress factor are very important. Now, if we see the requirements, these are the requirements. So, are we there yet? Whether we have fulfilled these sort of requirements which are needed for the better agromet advisory services or better agriculture assessment. So, some we have achieved, some we are working. So, those things I will show. Now, if I separate out polar orbiting versus geostationary, because for agrometeorology using satellite remote sensing, we have to club both the polar orbiting satellite data, which are providing relatively high resolution data, but less in temporal visit period. But on the other hand, geostationary meteorological satellites that provide the meteorological information. So if you blend this polar orbiting and meteorological satellites information, then I think this agrometeorology, which is basically crop weather interactions, can be actually satisfied. So we had actually a lot of discussion, I think way back in 2015-16 period, when Dr. Chattopadhyay was there in IMD, and we had prepared roadmap also, and after that roadmap also we have actually succeeded in some of the cases, but may not be in always, because there are many uncertainties also from going from the science to operationalization and actual adaptation of the products and its use. But I'll show you some success stories also. So India actually is having the ResourceSat series. So it is a 3-tiering imaging system, starting from a advanced wide field sensor, then linear imaging self-scanner, and LIS 3 and LIS 4. So you have 56 meter, then 24 meter, and the 6 meter resolution. But when resolution, spatial resolution is improved, temporal resolution is degraded. So from 5-day to 24-day, you can get from the same platform. But this is the optical remote sensing. But now you can tell that then we require the 5 meter or 3 meter kind of data or better than that. But then again, the temporal resolution will be hampered, and there will be cloud presence where we cannot use the data. So now there are a lot of private operators, and ISRO also planning. I will be showing all these things for the constellations of such high resolution satellite data for these better monitoring of the crops. And since you know that during cloud, optical remote sensing may not be good, so or maybe foggy situation. So there actually synthetic aperture radar is very useful. Just 1 minute. Just 1 minute. One call I have got. Sorry, actually, some call from has come from higher ups. Actually, this is the problem in our office by sitting giving the lecture. The synthetic aperture radar is very much useful for Kharif season, basically for cloudy period. And then if you see that currently we have a lot of satellites, resource 2, but those are very old now. Okay, and government policies are also changing. I'll be showing some of the things. And we have the recent this RISAT 1A, which is actually on. And apart from that, there are a lot of global open source data. Sentinel-1, Sentinel-2, Landsat, Moody's. Recently NASA ISRO has launched L-band and S-band SAR. These data will be rolled out soon from June onwards. And these data will be free of cost, open to the world. So this is the, but S-band will cover only in India and L-band will cover all over the world. So these are the current opportunities for the satellite data access and all. And you can see that if you see the AOIBS data, which are at 5 days interval. So simple from the false color composites, you can make out that how wheat is growing, how pulses is harvested. And so that dynamics of the crop automatically appears from the false color composites. But for crop classification, you need some more ground truth data for better classification and the accuracy. Now, these are the current situation. What is the future? Future, there are a lot of approved satellite missions from polar orbiting satellites. So we are moving for advanced LIS 3, which will be having 2 to 5 days revisit with 2 satellites and this 10 to 20 meter resolution. This will be complemented by HRSAT constellations, which will be having simple multispectral of 3.2 meter and LWI, that single thermal infrared channel of 17 meter, and there will be PAN. And apart from that, in future, there will be resource at 3S and 3SA, which will be much more finer. Now, can you switch off your phone? So regarding RISAT, there is a continuity of RISAT, but we require high resolution synthetic aperture radar data. And then if we see the Indian geostationary meteorological satellites, which have the coverage of Southeast Asian neighboring countries, so that has started from actually. Hello, Surendra, Dr. Surendra Singh, can you switch off your mic? Dr. Chattopadhyay, can you tell him? Yeah. So these geostationary meteorological satellites, which have actually gone all the through Kalpana 1, 2, 3D, 3DR, and now 3DS currently. And we have 4 kilometer thermal infrared, 1 kilometer visible and shortwave infrared, and temporal resolution is a 30 minutes interval. And if you can see just images, this is the these upper one are two visible images, and this is the middle infrared, mostly used for fog and the fire detection, and thermal infrareds day and night. You can see two thermal infrareds. You can see the temperature contrast and the cloud effect. On the other hand, we had inside CCT from geostationary satellite very good spectral information in red, near infrared, and shortwave infrared, 1 kilometer resolution. And we have come up with the NDVI products, and IMD has used a lot of these products up to 2015 till it had worked for National Agro Advisory Bulletin. So then we have realized that 1 kilometer is not sufficient from geostationary. So now there will be a launch in 2026. This GISat 1A geostationary imaging satellite that will provide 40-meter spatial resolution in visible near infrared, from where you can get the vegetation index and a lot of variables like leaf area index and all this. And it will be complemented by 1 kilometer thermal infrared, and there will be hyperspectral also, but it is at coarse resolution. So now from INSAT 3DS, we will be moving to future for the INSAT 4th generation, which will be much more advanced, but it may come maybe around 2030 or so. The uniqueness is that it will be having the advanced baseline imager and also the lightning imager. And advanced baseline imager will be having again multispectral bands. The important thing is that you will be having the multiple acquisitions in a day from this sort of advanced 4th generation satellite. And there will be other satellite payloads also, which I am not detailing here. Now, given this scenario and also changes in the government policies where we are, so we call this age as the new space age in agriculture. Why new space age? Because earlier, mostly satellite remote sensing and their usages were being done by government departments, either civilian departments or maybe defense. But nowadays, this space ecosystem is opened up, maybe around 2008 or 10 onwards, to opened up to the private entities, private satellite operators, and that's how you have seen that ISRO has launched 104 satellites of US, which is now called the planet constellations. But that was for US and other countries. They are providing those constellations for the globe, but which is a priced product. Now, India also has taken up the new space policy in 2023, and from that Department of Space, apart from ISRO, we have the InSpace, which actually promotes the private participation, and also NSIL, which takes the commercial contract. And they are actually promoting these private entities, and there are different type of things are happening where actually these Earth observation public-private partnership model has come up, who announces the announcement of opportunities for different type of challenges, thematic challenges in agriculture through AO program, announcement of opportunities, now seed fund program, and also building the satellite for consortiums. And they have given such contract to such consortium for the constellations. So these are the homegrown activities. And apart from that, also even in the government, like Ministry of Agriculture, they are also engaging different private partners along with the government agencies like ISRO for carrying out these exercise for claim settlement for Pradhan Mantri Fasal Bima Yojana. And also, there are different regional operational agricultural services based on satellite remote sensing, which have come up. One is Maha Agri-Tech program in Maharashtra. One is Gujarat Digital Agriculture program, where they have given the contract to the private entities, and where ISRO are helping both government and these private entities through their technology and expertise. So, and you can see that there are a lot of Earth observation satellites which are actually being operated by private operators, and in future also there will be plenty. However, and there are of very good resolution, very good temporal resolution, spatial resolution, but radiometry sometimes is compromised both in the multispectral, then thermal infrared, then hyperspectral, and also the synthetic aperture radar domain. These are all constellations mostly, but if you would like to access this data, there are different cost norms for academia. There may be reduction in the charges, but definitely it involves some cost. Okay. So now with these opportunities, how we can go for the deriving these EAV crop variables. First is crop type, then LAI, FFR, fractional vegetation, and crop primary productivity biomass yield. So I'll go quickly one by one. Now we have come to the age of the crop mapping using the satellite data. Maybe 10 meter, 20 meter data, time series data are good. So we can go for the object-based image segmentation followed by the machine learning. Definitely there will be some ground truthing required, which can come as through mobile and the polygons, which can be overlaid over the images and the stack of the data. Primarily we use the NDVI for the classification, and also the temporal backscatter profile for synthetic aperture radar. And you can see that how well this crop classification is made with very high accuracy using machine learning. You can see the different types of the crops in a given region. Here also using synthetic aperture radar, you can well segregate the soybean and the cotton crop. So if you want to build the crop specific advisories and farm level advisories, so you have to do the very precise crop mapping exercise. Okay. So from the machine learning experiment, we have come with a tool, that is the crop mapping using the automated machine learning approach, that is called the Shashya. So this Shashya tool is developed at Space Application Center, and we have integrated this tool to our Bhunidhi server of NRSC, from where you get a lot of polar orbiting satellite data. So this tool has been developed primarily for utilizing the EOS4 data. The advantage of this tool is that you need not download the data at your system. If you get access, so this is very important. If you get access from Bhunidhi team, so you can upload your ground truth data for a given region, and automatically the classification will be made by selecting the data in that system, and you can have the classified map and the probability map, which you can download, but the original data you need not download. Okay, so that is the advantage. We have trained this tool to MNCFC, that is Maulana National Crop Focus Center. But however, in future, this tool will be opened up to different participants, and with European Space Agency, we are going to conduct one training workshop during September 2nd fortnight, but exact program has not been finalized. But there, actually, we would like to demonstrate and give the hands-on experience on our this socio tool, and also the European Space Agency's tool. They have also come up with Sen4 Agri tool. So both the tools will be demonstrated mostly for the Indian and some of the Southeast Asian country participants. So you just look for the announcements. Maybe I can share once announcement comes with the SAFOAM WhatsApp group. So then suppose we get the time series data. What we can do? If we get the NDVI, LAI or so, we can actually make the compositing and also phenological information. What is the sowing date? And if you see from simple insect 3SCCD data, how nicely different sowing dates could be captured for Indo-Gangetic belt, covering from 1st November to 20th December in the Rabi season. And also, if we get the NDVI data time series, so then you can, if you see the 1 year to another year, there are a lot of changes in the harvesting date. And basically, from the receding profile of the NDVI, you can predict basically from the machine learning that when can be the harvest date, ideal harvest date possible. And you can see that impact of the COVID actually made a lot of anomalies in the harvesting date and the decline phase of the crop. And this paper we have published in some good journal. Now, how to estimate the crop LAI or FFR using the multispectral surface reflectance? We generally use the earlier people used to have the regression models. Now we have gone for the canopy radiative transfer model. So I am not going into detail. Canopy radiative transfer model actually simulates the spectral reflectance. So from satellite data, if you get the reflectance, you can actually retrieve back the LAI or FFR, which is hidden in the canopy radiative transfer model itself. So there are many ways to handle these models. And if you see that when we talk about Sentinel-2, 10 meter, you can get this sort of FFR value. If we talk about Planet Lab data of 3 meter, you can have well segregated plots where FFR values are seen. So it is not mixed up. Then another important is that drone image. If you further go in the high resolution, which drone provides, maybe at centimeter resolution, you can see the very subplot information and also the LAI using the similar kind of model. When you can compare with the satellite-based 10 meter data, you can see that those information are actually lost at 10 meters. So it depends that how contiguous crop patches are there, and we really require some kind of satellite constellations, maybe at 3 meter, 1 to 5 meter resolution. So that will actually serve the purpose for the plot level understanding and assessment. So then we move to crop yield estimation. There are different approaches which are actually crop specific, season specific, and the physiology specific. So crop yield, when we talk about, it may be grain, it may be tuber, it may be stem, or it may be fiber. So models actually vary depending on the. So generic model is a crop simulation model, though specificity comes as per the crop types. However, we are actually emphasizing on the two different models for adapting to satellite remote sensing. That is the light use efficiency based approach, which we call the semi-physical model, and another is the evapotranspiration based models, which we call the agrometeorological model. So these models we have tested for various crops, and we know the advantages and disadvantages. And also you can have the machine learning approaches where you can blend optical remote sensing data and the SAR data, and if you have good amount of crop cutting experiment data, you can build the training models. This is one example for sugarcane. Sugarcane, the thing is that SAR actually penetrates deep into the canopy, so it can sense the water content of the stem. However, the optical data can senses, optical short wave infrared band can senses the canopy. So both the things we have utilized together to build the model for Gujarat and Maharashtra sugar mills, and we have published this paper, and this can give you the good results. And these we are going to upscale for different parts of India. Actually, one company is closely working with us, which has two companies actually. One from Gujarat, they are catering the needs for the some of the Gujarat cooperative sugar mills for the better management, and also there is another company from Karnataka. So they have also signed the technology transfer document with us, technology transfer agreement with us on commercial, providing the commercial service using our technology for the sugarcane management and yield prediction. These another very important field is that crop insurance claim settlements. As I have told, that area yield insurance and the midterm weather advisories due to different perils. So, Government of India, especially Ministry of Agriculture, have taken up ESTech, that is yield estimation using technology under Pradhan Mantri Fasal Bima Yojana, and also the weather information network data system, that is WINDS, where mostly in WINDS IMD is involved. We are also part, but the structure of this is different. And ESTech structure is that there should be state, then insurance companies, and TIP, Technical Implementation Partner, and MITR, that mentoring agency. So mentoring agency, actually ISRO acts as the mentoring agencies. ISRO's technology are being used by TIP. TIP can be government or private, and then they provide both to the information on the area and yield to the state, and then IC should agree to the state level information. So it is at the Gram Panchayat level yield estimation that we are focusing here. That is the primary requirement. So the initial requirement was on the crop model matrix. So there are 5 models which have been selected: semi-physical, crop simulation, AIML, crop health factor, and NSML model. And it was decided that there will be weightage given to the satellite-based yield for up to 30%, and rest weightage will be given to the CCE-based yield. And now primarily it was for rice and wheat. Now from CMM1 to CMM2, we are moving to add more crops. Now soybean is also added. So 13 states in India are adopting this ESTech technology, and these are some of the examples where insurance unit wise yield actually are being generated and timely it is being provided. And one good story is that there was Maishuk cyclone over Andhra Pradesh, and there were some issues in the crop claim settlements. So we have made some special corrections in the yield using the satellite data, and 5,000 farmers additionally were benefited in 2 districts of Andhra Pradesh which were affected by Maichu. So that was a written communication from Andhra Pradesh State Department to us. So this is the success stories. And another success stories is that many states are now considering that weightage of 30% to the satellite should be increased to some say 50%, 60%. Even Madhya Pradesh has gone for 100% weightage to the this satellite-based field for the crop insurance. And Ministry of Agriculture has also informed us that after using satellite remote sensing, premium rate has reduced from 17% to 12%. So these are some of the achievements, and it is actually long-term things, and it will grow in future also. And there are mid-term advisory related to the weather-based insurance product. Frankly speaking, when I'm talking about the winds network and all, which are primarily dependent on a lot of high density in situ based weather data. However, there are no standardized indicators which can tell that yes, these can be used as the insurance products. All are actually, I could not get proper references of those indicators or thresholds which are actually used in the revised weather-based insurance and I talked to several people of the universities and several experts. So that's why we thought that let us make some initiative to bring, develop some satellite-based insurance, weather insurance product. So this is our first product of satellite-based rainfall insurance product. Though it has not been operationalized, it was as the experimental phase only. We have used both rainfall deviation only, and the rainfall deviation without any impact on the vegetation, and rainfall in deviation with the vegetation deviation with some lag response. So these three type of indicators we have made, and last indicator was found to be very good with respect to the yield anomaly at the GP level. And then if you see that this indicator nicely actually captures this rainfall deviation and their impact over some parts of some districts of Andhra Pradesh, which we call the SRIP 3. So these are some of the examples, and we would like to push or work some more on the heat anomaly and heat related things for the Rabi season, which is also causing problems for the yield reduction. So our future endeavors will be on this weather-based insurance product development from satellite. Now I am coming to the soil variables part. Soil moisture is very, very important, especially surface soil moisture from satellite, and land surface temperature, soil or canopy temperatures, and in addition to that, soil carbon and soil salinity. So this is the glimpses of the C-band operational surface soil moisture product, though at little coarser resolution, 500 meter resolution, at 17 days interval. But this is the first operational satellite from Indian synthetic aperture radar. This is available from Bhunidhi without any cost. If somebody wants to use it, they can use for this. And now this is the time series of the India mosaic of the 500 meter soil moisture products from the RISAT-1 C-band at 17-day interval. And now we are moving to more advanced products that will be 100 meter resolution from the L-band and S-band SAR of NASA ISO synthetic aperture radar, and this is one of the examples of that surface soil moisture. And you can see that how nicely the different variabilities could be seen from the low to high moisture situation. Now it is at the Calval and experimental phase. Now more applications, more assessment will be done. I think by end of this year, this will be definitely operational. And then we have carried out one experiment with Indian Agriculture Research Institute that how to arrive at the farm scale soil moisture combining synthetic aperture radar, thermal infrared, and the optical remote sensing data. So this is one example of the ensemble soil moisture from the different type of the remote sensing observations, and this paper is published in Agriculture and Forest Meteorology. And you can see that in IRI farm, how nicely with respect to the different irrigation regimes, actually soil moisture, surface soil moisture is captured. But still, this root zone soil moisture at high resolution is an issue, and this needs a lot of modeling exercise, a lot of data to be incorporated, and understanding that how it is behaving, whether it is really simulating the root zone soil moisture from satellite data or not. Now, this is one study on soil carbon from space. What I am showing is not my own work only. It is the collective work from the team at Space Application Center who are working in agriculture related domains. So basically, when we realize that soil carbon needs to be understood for different spatial resolutions, from 5 kilometers to 10 meters. So we have made one deep carbon model neural network system, and here we could get a lot of data from different parts of Gujarat, especially Anand Agriculture University, and from the dairy units also. And we could make this kind of demonstration studies for this multi-scale soil carbon estimation where we have used satellite remote sensing, digital elevation model, and also spectroscopic data for building the libraries and also training. And these you can see on the left hand side, the SOC at very coarser resolution, but when you zoom it to 10 meter, you can get this sort of variability at 10 meters. So this paper is published in European Journal of Soil Science. Now with Indian Institute of Technology Kharagpur, they have the proximal sensing units. Then we chipped in with them how to upscale or how to replace the manual wet chemistry method for soil carbon estimation. So there was a lot of calibration between these simple RGB methods of photography with respect to the wet chemistry methods, and then those models were upscaled and then further upscaled to the regional scale. And this paper actually gives a better economic benefits in terms of large scale and quicker soil carbon estimation using proximal sensing and digital soil mapping. So this paper is also published in Soil Advances, and now using the spectroscopic technique like imaging spectroscopy, which we call the hyperspectral remote sensing. We had the airborne campaign with NASA. We had the good data set for different parts of India, both the ground data and the airborne hyperspectral at 4 meter spatial resolution. So when we have analyzed, we could find out the absorption bands, which you cannot get from multispectral broadband data. So from the hyperspectral, you can get this sort of narrow absorption bands, and in continuity of the bands, you can actually make the absorption depth. So there are absorption depth, then absorption area, and various parameters you can derive from this sort of absorptions. And based on that, we fitted the model in this neural network system, and those model predicts very well good variability when we have used with the satellite this airborne data. And this paper also published in a very high rated journal. Now, what we should do with the soil carbon, soil salinity, and all these things. And as I told initially, the desertification and land degradation is one of the major challenges for the climate change impact studies. So, our colleagues have actually are doing this desertification and land degradation study, and this is the latest atlas using the 15 years of changes using remote sensing data. And this is atlas is available with Ministry of Environment and Forest, and this is released also in the this COP16 in Riyadh in December 2024. And now we are working on land degradation vulnerability assessment. And if you see that this desertification changes actually has occurred mostly on the agriculture dominated areas, though there are different slopes and runoff conditions also. So processes I am not elaborating. So these are actually ongoing work. Sorry. So after land degradation, then I will come little bit to these meteorological products, which are very useful for agrometeorology. So I will not be touching on satellite rainfall, but satellite-based surface insolation, that what is the incident solar radiation, that is very important. We have already published literature, and based on that algorithm, we have come up with a half an hourly and daily integrated solar radiation. There are more than 23,000 GB downloads of these products from our MOSDAC system. And these products have long-term genesis from Kalpana 1 to Insert 3D, 3DR. And that's why these data is hosted in Veda's platform, and a lot of renewable energy companies are using for fixing their new solar farm. And also here, the solar power forecasting is also being generated. So there is a lot of usage of these products, and now we are moving from not only Indian or Asia specific system, we are now merging the solar insolation products from different geostationary satellites of globe, and this mosaic shows these global daily insolation products. Very soon we will operationalize it in MOSDAC. And now, once we get the good solar radiation and also short range weather forecast from IMD, though forecast comes with the solar irradiance also, but we have seen that solar irradiance from the forecast is not good. So it is better to use the daily shortwave radiation from INSAT and use other weather elements and put it into FAO 56 model for come up with the reference evapotranspiration. And a lot of agencies are downloading this PET, and we have more than I think more than 3,000 GB download of the data by 39 agencies. So now these daily reference evapotranspiration, we have the long-term series, and we have made 10 years of daily normal of the reference evapotranspiration, which we call the potential evapotranspiration also. And based on the request of AICIPM, All India Coordinated Research Project on Agrometeorology, we have handed over these daily normals to them, and I think it will be, and they have also initially evaluated this data with their ground systems, and they found it good. So these are the usages, and since we have these daily PET and long-term PET, so we are trying to predict the PET for next 1, 2, or 3 days. So day ahead PET, 3-day ahead PET, like that, using the machine learning approach. So this is one such example for that. But still, this is an ongoing thing. And then another very important thing is that thermal remote sensing and land surface temperature, which is very, very important for detecting cold wave and heat wave. So this is the land surface temperature products, and all our Indian geostationary satellites are having land surface temperature products, but maybe at coarser resolution of 4 kilometers or so. But still, if you get the half an hourly data of land surface temperature, in the night, you can come to know that what is the persistence of the cold wave and what is the cold wave zone, and what is the heat wave zone, what is their persistence. So that kind of thing, and if you overlay crop over that, suppose wheat, mustard and all, you can come to know that which crop is going to be affected. So these are the usages of that. Now in thermal infrared remote sensing, we are coming to high resolution thermal infrared sensing at 3-day interval in form of ISRO Indo-French Trishna mission, and which is very focused towards the irrigation management. And before that, we have used the eco-stress data, which is on International Space Station, and landscape data together, and come up with a surface energy balance solution and crop evapotranspiration at 70-meter resolution. But in Trishna mission, we are focusing 60-meter spatial resolution, but at noon time, because for evapotranspiration, if you want to estimate properly, you should have thermal infrared observation at noon time. Okay, maybe at 12:30 or so. And when you have converted the water stress, you can come to know that what is the within farm variability of this water stress factor. But still, we are not satisfied. We would like to downscale it with more finer resolution satellite, so that precision scale water management or irrigation management can be possible. That's why we have actually done some experiments with the drone thermal remote sensing. Still, that experiments are continued. And if you see that this is the drone thermal images, very high resolution variability you can see in the temperature. Wherever you are seeing the bright plots, those are either harvested or at the matured phase, where you are getting this low temperature, that is at well water or well cropped area. So this is some parts of Gujarat. And when you are clubbed with the RGB images, you can come to know about the moisture availability, and also within the plot you can see the what is the differences in the moisture availability. But drone thermal remote sensing every day you cannot have, because it calls for separately, it requires a lot of logistics and data processing. So we have to bridge somehow the high resolution, maybe 10 meter, 20 meter evapotranspiration from these future missions, as also the optical data which are available at the satellite constellations. Now, for the agro advisory systems, what we are providing, we have interacted with a lot of agromet field units which are in Gramin Kishi Mausam Seva of India. Dr. Navangshu knows very well. He has handled, and they have demanded that these are the different sets of data they require at the block level. So these are the PET, aridity index, minimum and maximum land surface temperature, NDVI, and soil moisture. We provide it through our Vedas platform, through FTP, and they have provided their block level these vector layers, and these data were actually averaged and put in the CSV format every day. And this is going on for last 4 or 5 years, and our social research team of ISRO actually has made some independent survey, and they have come up with the conclusion that when their farmers are using in Parbani, Maharashtra, using the satellite based agro advisory, there is 8 to 12% economic benefit in terms of input use reduction, as well as slightly increase in the yield, especially for the cotton and soybean crop. And this paper is published in Current Science in this 2025, and we are more working on these and the different aspects, especially for the high resolution agro advisory product and the prediction from that. Now, towards prediction, weather forecasting and extreme events play a very, very important role. So, however, as I have told, that land data assimilation is one way to do that. But however, in India, this operational land data assimilation did not take place. We have taken some experiments from vegetation fraction, which we derived from INSAT 3A and used in WRF for land data assimilation, and that showed that at least from central to western India, you could have the better rainfall prediction as compared to the default parameterization. So this paper also published, and now another important part is the pest forewarning, pest advisory. There we use satellite-based crop map, crop stage or phenology from satellite, and also weather forecasting. And then ICR has developed the epidemiological models. So this is example of this mastered aphid through which we have developed the geospatial pest forewarning system, and this geospatial pest forewarning system is also hosted in ICR, this platform in knowledge ACMU, that is Knowledge Management Center or like that, and we are working more on several other crops, and it is great to, you will be happy to know that some private farm from Gujarat who is providing geospatial service, they have taken this technology. We have done this transfer of technology through commercial terms, and they are using this technology for the Gujarat. Now, last part I have come, which is actually burning topic, that is digital agriculture. That means everything should come on the digital platform so that comprehensive decision making can be done. So ministry has come, Ministry of Agriculture, Government of India has come up with the Krishi Decision Support System. You can just Google it and see that what are these. A lot of progress is being made, and we are also deeply involved with their efforts, and how ISRO is helping in that. We have developed the National Geospatial Drought Portal, where IMD and also Ministry of Agriculture, MNCFC was involved, and this is the first time Indian drought manual actually has been implemented through the geospatial data, both satellite remote sensing in situ and other sort of management related data. So these actually is highly popular for the policymakers and also for the different states. And ISRO is empowering with the different products from the different satellites from current and the future. And also we have made the yield estimation systems, which we have targeted for 11 crops, but for the time being, we have made for the 4 crops. You know that Ministry of Agriculture has a fossil as a flagship program. They want district level and state level yield estimation before harvest. So this system we have made as a dashboard, which we call the GeoCrest. That means geo based crop yield estimation system. So this is at the developing stage. We will, I hope that by end of this year, we will hand it over to ministry, and it will be also integrated to the Krishi Decision Support System. So Krishi Decision Support System has several modules like crop estimation, disaster impact, crop insurance, soil and agroforestry, and fodder. So this was inaugurated by Minister and State Minister, and also our director, the then director, in 2024. Now, as a follow-on to that, now different states also have taken up the digital agriculture monitoring initiative. So Gujarat State Agriculture Department have launched Krushi Pragati, which is totally based on satellite remote sensing and the mobile technology. They have actually established big command and control center in Gujarat State Agriculture Departments, and they have given the operational contract to some private agency. But however, what is the role of SAC and ISRO? We are empowering the NGE by transfer of technologies, I have told, for yield and pest forewarning. This is actually published in newspapers also in Times of India. Through InSpace and NCIL route, we have transferred this technology, and we are also chairing and guiding the technical verification committee, and also SAC is doing the quality control checks of whatever these NGEs are producing the results. Now, day by day, it is improving. There's estimates and assessment, and this is, you can see that for multiple of crops, some 19 crops and 28 crops for Kharif, Rabi, and some are 9 crops. So the multiple crops are actually mapped, and their yield estimation are done at the taluka level, that is less than almost block level or equivalent to that. So with that thing, actually ISRO has a lot of geo portals, Bhunidhi, Bhuvan, disaster management portal, then MOSDAC for meteorological data, Vedas for the high resolution earth observation data and analytics, and the NICES for the climate data. So you can surf and see that what is how you can get those data if you are interested. We have the international collaboration with NASA for advanced satellite making, like NASA ISRO SAR, which has been already launched in 2025, and Trishna, that high resolution thermal infrared mission, which will be launched during 2027 or early 2028. It will be followed by a lot of global other thermal infrared missions. So it will act as the constellation of thermal infrared. Primary objective is to have better agriculture, water management, especially irrigation management, and these will be providing these essential agriculture variables like soil moisture, land surface temperature, leaf area index, evapotranspiration, and crop biomass. So we are working on the algorithm prototypes, and these products will be operationally available. Now from the NISR, now we are working on net sown area, how that can be a product for a Kharif season and the Rabi season, that we are working, and by the end of this year, maybe from NRSC Bhunidhi sites, we will integrate the algorithm, and these products will start coming. So with that thing, I will conclude with our future focus, that our basic focus of our group is to develop the different algorithms and operationalize it for farm scale EAVs, essential agriculture variables, not only for agromet services, for other applications of agriculture also, but agromet services are one of the important things, using combination of these advanced satellites, then advanced resource sat in future, and INSAT 4th generation, and other satellite constellations. We are we are making digital agroclimatic atlas. Now we're using the long-term data, primarily first with Punjab and Maharashtra. If it is successful and useful, then we will scale it up for whole India. and then how we can do predictive modeling from the time series data for the using the satellite products for forewarning using the artificial intelligence. So these three are our future trust, and we are coming up with a book on space for food security. So this will be ISRO facilitated book publication, though it will be publisher will be from outside. So maybe by the end of this year, we'll come up with this book. First draft is already ready, and this will go for several revisions and all. So I will inform about the publications of the book. That will be very, very useful for any students and faculty. So with that, I thank Dr. Nobangshu and all the participants who have the patience to actually to listen my this long lecture. Thank you.